Hello, 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 hello. Why do all these reflections on my lawn are white? And why don't we see the effect of dispersion? The reason is that snowflakes are not transparent water drops. If they were, then for sure you will see dispersion. You will see in different directions different colors of your water drops. But they are not. And so that, in a nutshell, is the answer why you don't see dispersion. It's not even a transparent prism, let alone a water drop. The light reflects off the surface without ever getting into the water and coming out of it. So it's like a mirror. And so it reflects the same color to you of the halogen light, and that's very close to white light. So that's easy. Why all of them look white and why none of them show dispersion. They would show dispersion if they were transparent. That means if the light could enter and come out again, but it doesn't. Why, when I close one eye, do I see about half the number of white dots on my grass than with both eyes? Let's look at that in more detail. Here's one eye, here's another eye. They are separated by a distance capital L, which is about roughly 10 centimeters. Let us make the simplified assumption that the light that comes from the halogen light, all that light is parallel to each other, which is not exactly correct, of course, because the light has a certain finite size. But let's assume that it's approximately correct. So all the light then comes in parallel to each other. If there is here a snowflake, then my eye here will see that snowflake. Light comes in, angle of incidence is angle of reflection. If this were a flat mirror, I assume it is a flat mirror, then I would see this light. But this eye would never see the light from that flat mirror because it's too small. If I put that flat mirror here, then I would see the light reflected from this flat mirror, from this snowflake. So that means if the snowflake were this big, which is about 10 centimeters, oh yeah, then both eyes could see the same snowflake. Now this, of course, is a simplification, that these snowflakes would be perfectly flat mirrors. Let's assume that the snowflake, it's another simplification, partly flat here and then at an angle theta in a different direction. Then, of course, one eye could see the reflection of this part and your other eye could see the reflection of that part. Then both eyes could see the same snowflake. And you can make a simple calculation, then as long as theta is 1/2 L divided by D, then both eyes could in principle see the same snowflake. And if D were 10 meters, then the angle would have to be 0.3 degrees, and for 100 meters the angle would have to be smaller. So that indicates already that the farther away I could have looked, but of course I can't look any further than the width of my garden, which is about 10 meters. But the farther away I could have looked in principle, there would be a time that both eyes might be able to see the same snowflake. But in practice, trust me, I have tested this many times by closing one eye and then closing the other eye, and then half the white dots roughly disappear. It's very interesting. So I look at the bright spots, I do this, half of them disappear, I do this roughly, and the other half disappear. So that's the reason why my camera sees half the number of white spots than I do. Because I have two cameras, one here and one there. Okay, so that was an easy problem. Have a nice day, take care, and yes, we will be friends. And by the time I will be posting this problem, I hope it will be spring and not winter anymore.